Building IoT solutions is an engineering business, but not just software engineers. We have other types of engineers contributing their skill sets, their knowledge, their subject matter expertise. You can have chemical engineers, you can have mechanical engineers, data scientists as well. They all contribute to building these end-to-end solutions. But not everyone can write code. How do you do that? TwinThread is one of the solutions that allows you to bring together all these engineers around a tool that will make building these predictive operation solutions super fast, super efficiently. Eric from TwinThread is here on the IoT Show today to tell you everything you need to know about this solution that is available on the Azure Marketplace. Hi everyone, you're watching the IoT Show. I'm Olivier, your host, and today we'll talk about industrial IoT solutions and especially around the different types of engineers who are involved in operating but also developing these solutions. TwinThread is one of our partners. They have a great solution that brings the added value, the glue on top that will make developing IoT solutions end-to-end super fast. And I have Eric from TwinThread with here to tell us everything you need to know about what's going on that side of the world. Eric, thanks for joining the show today. How are you?
Olivia, thanks for having me.
So tell us a bit about yourself. How long have you been in the IoT industry? What is TwinThread? What was the inception of the company, the products, and so on in there?
Sure. I've been working in industry for going on 30 years. My background is as a chemical engineer, but I always, from the very beginning, was implementing software solutions. And I would add, I've been implementing software solutions on the Microsoft tech stack for that entire time. And TwinThread, really, the idea behind TwinThread was to take advantage of some of the very latest technologies in particular around machine learning and cognitive services that Microsoft made available and really bring them into the industrial market for rapid application development.
So Eric, the industrial IoT space really put focus on an aspect which is not new but more and more important and visible, which is that in solutions, end-to-end solutions, especially the ones that are about predictive maintenance, predictive operations, and so on, different types of engineers are actually playing their part. Tell me a bit about that.
Yeah, as you mentioned, as the solutions are getting broader and broader and covering domain-specific topics like predictive maintenance or perhaps predictive quality, really the set of expertise that's needed to implement those solutions is very broad. What starts off with traditionally the IoT device software engineers working together with now process engineers and chemical engineers, industrial engineers. And so we think it's really important not just to view that part of the engineering community, meaning the process engineers and the chemical engineers, as users of the IoT solution. Rather, we really need to transition to bringing them into the developer community and thinking about them as developers of the solution.
I like what you're saying, because I think lots of people in that space would say, hey, I'm building that IoT solution, I connect the devices, and then there's going to be some magic data or models that are going to be applied to extract insights and make things happen. But very often you forget about the fact that these models, the specificities of the operations and so on, are something that is very specific to a domain, to a realm of engineering that the software developers don't know anything about. I think it's great that you're approaching that problem in a market that goes faster and faster. I mean, competition is there. Yes, you have your own value add, but if you waste your time at implementing bits and pieces that are not, once again, not part of your skill set or your responsibility at the end of the day, you're wasting time that's translates into losing business, basically.
That's right.
Oh, I think you came with a video to kind of like put some visuals over all of that. I think it's all very interesting discussion, but let's look at, how TwinThread is approaching things to help these various types of developers and engineers out there.
Yeah, so what I'm about to show is really how TwinThread can empower that engineer, and it's really the software engineer all the way up through the process engineer, chemical engineer, the whole community of engineers that we've already talked about up to this point. And again, the goal here is to accelerate the time to value and to limit the overall development time so that those engineers can innovate and get as directly to solving the problem that they're setting out to solve as possible.
Welcome to the TwinThread ecosystem. Our process delivers insights and actions to improve your operation. This video will help you understand our lingo and our system. Let's start with the elements you'll see on your home screen. A data source connects to systems that have critical information. In many data sources, the common name for each data element is a tag. In our system, tags are mapped to sensors. We use the term sensor because in addition to capturing control tags, they can also connect to more sophisticated data, like a production schedule, fleet usage, inventory level, or web order status. A twin is a digital representation of an asset in the real world, rendered virtually in the cloud. Properties are connection points into the twin, drawing data from either sensors or threads. Sometimes the data sources do not give you exactly what you need to gain the insight you seek. That is where threads come in. With a thread, you create logic that calculates the data you need from the data you have. TwinThread comes with a library of models to analyze your data. They're much more than a single algorithm. Models combine decades of experience with an intelligent engine to evaluate multiple algorithms and pick the best one for your situation. To integrate a model into your system, connect the properties of your twin to the topics of your selected model. It's a simple step to train the model. Then you are ready to set the system into execute mode so that TwinThread continually delivers the visual insights and recommended actions needed to optimize your process. Information is power, and the TwinThread system is a powerful way to see your information and use that insight for action.
Nice video. I think it's pretty interesting how it really highlights TwinThread in its simplicity, right? It seems to be pretty straightforward. And because we have developers, Eric, you're gonna have to show us how that looks like in real life. So the video really explains it, but I think people like to see how easy and simple, especially when we start claiming things like codeless and super easy. So show us what's going on in there.
Sure. So what I would like to talk about is what happens when you deploy a TwinThread system from a developer or a solution architect perspective. When you provision a TwinThread system, what happens automatically is all the supporting Azure services are automatically deployed. We're talking services like IoT Central, Azure Cognitive Services, of course, things like Azure Storage and Compute and so forth. And we also do some automated modeling, which we'll talk about in a moment, that's based on Azure Kubernetes services. So all of those base infrastructure services are automatically deployed, configured, and what you're presented with is the Launchpad is really a way of rapidly progressing through an implementation from the connection of all the data all the way through to the insights and actions. And what we're seeing here is example of that Launchpad that we're going to hit some important points in a demo here in a second.
Sounds good.
So I think it'll be actually better to show you a real scenario here. And what we're going to look at is a simulation of a wind farm, and that has many assets in it. This simulation is based off of some open source data from a wind farm in France, and we're going to kind of walk through some of the important parts of the solution and how you would configure and build this solution.
Hey, that works for me.
What we're looking at here is an overview of a wind farm where we see kind of a live picture of each wind turbine and some key metrics about those wind turbines. And this data is flowing in from potentially many data sources, flowing through IoT Central, and potentially from other systems into this view. What we're looking at is a digital twin, and what you should know about TwinThread is that a digital twin can represent not just an individual device or an individual machine. It can represent a whole collection of machines, as well as the processes that are wrapped around them. So here I'm looking at a wind turbine, and I can drill in and I can see an individual wind turbine. So this would be an individual digital twin where we have the visual representation of what's going on with that specific digital twin. And what I'm going to show next is how do I, as an engineer, how do I start to innovate around all of this data and around the digital twin that we see here. And that really starts with the concept of digital thread. We notice that off to the side of the screen here, we see that there are 9 digital threads running, as well as 4 models. We're going to talk about both of those, digital threads and the models. But you should think of a digital thread as something that's an automated calculation that's not just monitoring what's going on that asset, but potentially taking actions. And we'll go through a real example of what that entails. So I'm going to add a new digital thread to this wind turbine so that we can maybe create an alert based on a specific condition happening.
And so that we're clear, so the one who's manipulating that application right now, like the hat you're wearing, is not the farmer, right? It's going to be someone who has knowledge and he's an expert in the world of of these windmills, and he's able to actually understand what the data means and so on. So it's super important to actually specify that and explain what kind of hat you're wearing.
That's exactly right. So I am a subject matter expert as a developer I understand wind turbines, and I think it's a very critical point. As an expert in a wind turbine, I'm not necessarily documenting my requirements and then passing those requirements off to another engineer to develop some software, and potentially passing those requirements off to another engineer to develop other components of the system. I'm empowered to just go directly in using my knowledge and start developing a solution. And this is really what starting with the digital thread is all about. If I click on the plus button here and give this new thread a name, something very creative like new thread, and associate with my wind turbine project, when I hit create, I basically get a blank canvas around which I can start innovating, start building a solution here directly in this canvas. And I do that through a whole library of pre-built functionality that, as you'll see in a moment here, I basically drop that functionality onto the canvas, connect the dots, and create an application from that. So what I'm going to create first here is I'm going to pull in some sensor data into my thread that I'm creating here. Then I'm going to perform some logic on that. And in this case, I can write a small snippet of C# code if I wanted. So, we talk about the no code, low code environment. We're not excluding any code development. We're just trying to minimize it down to the absolute minimum.
Yep. And it happens so that, anyways, there are engineering domains where people are used to use specific languages, right? So machine learning, you have R, Python is very much used by data scientists as well. So there's no reason not to introduce development languages as well, if it makes sense for the engineer manipulating the app right now.
That's right. You got it. And so I'm continuing on here to, let's say, bring in a sensor value, perform some logic on it, evaluate whether there was a change in state of this piece of equipment, and then based on whether there was a change in state, perhaps I wanted to create an alert. If I can find it, create an alert. And then perhaps I want to also send a text message to a specific individual, a group of individuals, when that particular event occurred. So at a high level, what I've done is I've just dropped these blocks on the canvas, connected the dots, and created a small application here that not just pulls in some sensor data and does some analysis on it, but rather also takes an action, creates an alert, sends a text message, and you could potentially, if this were, let's say, a maintenance-related problem, I can drop another block on there, which will create a work order in a work system automatically. So it's more than just calculation. It's actually doing analysis and also taking actions all in one single development environment.
And once again, the big value of TwinThread here is that the person who is doing that is not the software engineer who's been building the solution underneath. It's actually the wind turbine expert, the engineer or maintenance guy who's going to work on that and knows how to drag and drop stuff, and also then knows the specificities of wind directions and things like that, because that's his realm, that's what he's an expert in. Or it could be the various parts of that wind turbine that he wants to diagnose or monitor. So definitely, instead of having to interact, as we were saying, passing on a set of requirements to a software engineer or to a software architect and wait for the next iteration of the application, he can build it himself. He can actually contribute his own knowledge and skills to it.
That's exactly right. What I'm going to show next is how to add a model to this digital twin. So in a way, we've just added some new capabilities in and around that digital twin, something that didn't exist before. So it's an innovation in how that wind turbine operates through the power of the digital twin. The next thing I'm going to do is add a model, something that's going to apply some machine learning to try to achieve some type of result on this particular wind turbine. You can see in this example, we've already have a few models that are currently running on this wind turbine, namely looking for anomalies, so doing anomaly detection on that turbine. We have another model that's trying to optimize efficiency, and that's really, it's trying to optimize the conversion of wind into actual power, and how you might adjust that operation of that wind turbine to achieve maximum efficiency. And then another is to predict power output. Maybe we're pulling in weather data and wind data and trying to forecast out in the future what is the likely output of this specific wind turbine given the conditions that are going to affect that wind turbine. So those are several examples of models, and just I'll walk through the process of an engineer adding a new model to this wind turbine. It's as simple as, again, clicking the plus button here and coming up with a very creative name like new model. And you'll see a difference here around models that's different from threads, in that I'm asked to select a template here. And in the video, it mentioned the many pre-built applications, and that's really what's manifests itself in these templates. So there are many, about 30 sort of very classic industrial use cases that are represented in this list of templates. One, for example, being predict event, the scenario where I want to provide advanced warning of some bad event happening on that piece of equipment. Well, if that's my problem that the engineer wants to solve, all they need to do is select predict event as their template, and they're off and going. I may want to, another example is optimize property. I want to optimize a particular parameter, such as optimizing the efficiency. So I'm going to go ahead and select that optimize property template, and you'll see when I confirm that, and I go into that model, what I see is it's already dropped all the blocks on the canvas for me. So it's already built out the application. And in a similar way that we saw with the creation of digital threads, I have these library of what amount to prepackaged data science steps that are necessary to build and train and then ultimately deploy and execute a predictive model.
And what's interesting as well is that here you have another actor, which is a data scientist who's been actually contributing to the application. As the wind turbine engineer, you're just leveraging the work of your colleague who's been actually working on these models and publishing them on TwinThread.
That's right. And if you're a data scientist, and allow me to sort of zoom out here a little bit to focus in on some of the early steps in this modeling process. If you're a data scientist, you tend to spend a lot of your time cleansing and cleaning and filtering and collecting data, and really, we hear many data scientists saying we're spending 80% of our time just doing that. And so our aim in the model factory, what we're seeing right now, is to automate those steps so that you can apply those steps at scale. I mean, the reason why we call this the model factory is we view it as a digital assembly line where the inputs are data and the outputs are trained models, potentially thousands of personalized trained models. And we don't want the data scientist even to waste any time on the mundane steps of collecting and filtering and summarizing that data to get it properly formed for modeling. We just want to give the tools to go straight away and address the business problem.
Thanks.
So in this particular example, I'm looking at the train operation for our wind turbine efficiency example. And you'll see these blocks that say things like collect data, summarize data, merge data. Then you also see a step here called optimize features. This is what we found is a very important step in any predictive application deployment, and that is even a knowledgeable engineer in the equipment may not know all of the things that impact efficiency, for example. So what we recommend doing is including all of the inputs about this wind turbine into the model and allow that optimize features step that I highlighted here to automatically determine which parameters have predictive power over what we're trying to accomplish and which ones do not, and automatically isolate the list of the most important items. And then after having done that, go in and train, in this case, multiple algorithms. It may not be predetermined whether it is a neural network algorithm or whether it is a random forest algorithm is going to perform the best for this specific situation. So what we do is we train all of the possibilities. Sometimes it's 5 and 6 and 7 different algorithms, depending on the use case, to automatically select which one's going to perform the best in this specific situation. And then after doing that, automatically deploy that model into production. So there's a lot of development and DevOps steps, if you will, that are automatically being carried out behind the scenes, if you will, based on what you see here in the model factory, and it just saves an enormous amount of time in the development process.
Definitely, I can see that. So you're at the point where you have this model, so you want to apply it to your application, right?
That's right. And so when it gets to the end of this training process, it'll automatically deploy this model into production. And some of the things that you get out of a model, just to highlight this, is we like to call it the exhaust that comes from the modeling process. I clicked over here on the analysis tab, and this is going to show me a whole bunch of analysis about what the model has learned about the process in the course of modeling that particular asset. And one of the most common things to want to understand are what are the top drivers that are impacting efficiency in this case. And so if I drill into that, what I see is that the top driver for efficiency is what is the converter torque or the overall torque, as well as things that you would expect like the generator speed and so forth are having an impact on the overall efficiency. So if I wanted to understand what the features were or what the variables were that were impacting overall efficiency, I can just go straight to that from the modeling process, as we see here. Okay, going from analysis, you may want to build some of your own analysis around the model. And so let me kind of set up that. If I go back to the layout of the model and go to the training, what I see is in between each one of these blocks in the training process, I can access a data set. So what I'm drilling into now is just looking at a preview of the filtered, summarized, curated data that's come from this wind turbine that I'm previewing here kind of in a spreadsheet. But this data set is very, very useful, not only for modeling, but potentially for many other uses throughout the business. And so what I'm going to show next actually is how you can take that data set, and if I click on this button here, what it will do is it will publish that data set so that it can be easily accessible through Power BI. So if I jump over into Power BI, one of the things that I can see here is that under data sources, we have a specific endpoint, actually an OData endpoint, that is pointing to TwinThread. And when I open up that endpoint, what you see is all of those data sets that have been exposed through the model factory show up here. And I can just simply check the box and import that data set directly into Power BI. And I had done that ahead of time here. And as you can see, I'm looking at the same variables, basically, that were coming from that wind turbine exposed in Power BI. And the important point is that it's not just the raw data. This data has gone through all of that data cleansing and data filtering summarization so that it can be much more easily used in an application such as Power BI. So here's an example of I've built a trend off of that data, but I love these features of Power BI, for example, that allow you to do these key influencers. So here we've pulled in the what's influencing the bearing temperature on that turbine, and not surprisingly, the Power BI has told me directly here that the rotor speed, how fast the turbine is turning, is a big influencer. Is exactly what you would expect. But sometimes you're going to find surprises in these analysis, such as the pitch angle, which is the angle of the blade on the wind turbine. It's also having an impact on bearing temperature, and that's very interesting. And
Indeed,
the important point is that I really couldn't do this analysis very easily without having gone through those data science steps, if you will, to prep that data. And since we have that automated, someone who's developing in Power BI can really have a very fast time to value. And of course, the other feature that I love in Power BI is being able to ask the natural language questions and really get straight to visualizations and so forth in an ad hoc way that are very, very powerful.
the other thing I really like as well is the fact you just demonstrated that TwinThread is not the end of it, right? You are actually extending to business applications as well. We had it a little in the send an SMS or send an email, right, to someone else, to create a ticket as well. You mentioned the idea of creating a ticket for maintenance for something like that. And here Power BI definitely a new set of users will access that cleansed data and can do the job, right? An interesting aspect of it is that, as I see it, is that it's not always the same person, but it's not always the same company, right? Maybe you want to share, you're buying parts to create these wind turbines, and you want to send to the manufacturer of the blades that data so that they can optimize their blades, versus use yourself doing the whole process on your own. So actually, I think it's pretty interesting how TwinThread is adding value, really simplifying a certain number of things, but it's not closed. It's something that extends to business applications, and underneath, as you were mentioning, can ingest data from a set of services that are very diverse and very, you mentioned weather data eventually, in addition to the IoT data come from the wind turbines themselves. So
that's right.
Totally. So I think there was a very instructive and exciting demo, Eric. Where and what should developers of any kind actually do? What is it that TwinThread has for them? Where can they get started?
That's a great question. So we've recently launched on the Azure Marketplace, and so anyone interested in getting started and just trying something out, we have a no-risk offer out on the Azure Marketplace. So I would encourage you to go there and get started.
Awesome. Thanks, Eric. Developers, whether you're an IoT software developer or you are a data scientist or any kind of other engineer, if you are excited about TwinThread and the way you can easily deploy TwinThread in Azure, you can visit the marketplace, the Azure Marketplace, like Eric just mentioned. You can go directly to aka.ms/IoT show/TwinThread. So we'll bring that up here. Eric, thanks a lot. Great demo, great presentation. I really hope people see all the value that TwinThread is bringing on top of the Azure services.
Thank you very much, Olivier. Really enjoyed it.
Well, I hope to see you soon again on the show. And for everyone, hope you liked it. Do not forget to subscribe, get the notifications. See you soon. Goodbye.